All right, welcome to this video. We're going to continue working with the B-tree data structure here. And specifically, I'm going to continue working with the 2-3 variant just for practice. And one of the main reasons I'm going to do that is the 2-3 tree is technically the smallest B-tree. And so it's going to have the most splits involved. And we're going to want to practice using splits. So why not use the one that has the most? If we have a B tree like a 4-5 tree, we'll do fewer splits. Our nodes are larger, they can hold more. And then of course, in practice, when we're actually using these maybe to manage a database, our order is very large. And trying to play with a B tree of say order 100 by hand is just a waste of time, since it's just the first 100 adds will all be in one node. That's not going to be very interesting. So let's instead, as I mentioned, do a 2-3 tree. And so maybe just to get ourselves started, a 2-3 tree is going to start out with having one possible node. Technically, we could start out saying we have no nodes, but I'm going to say I'm going to start out with one empty root node. And I'm going to just go ahead and start putting elements in there. So the first thing we would put in would be the 11. Normally we just assume it goes into the first location like that. But we'll see that the next node that we would add is our 4, and then the 4 will bump down the 11. So we'll end up with something like this. Okay, so that's after the 4. Well, let's go ahead and add the 21. And usually when I do this, I think, well, the first thing I'm going to do is add the node in where it belongs. In this case, it's on the right-hand side. Now this creates a node now of size 3 in a 2-3 tree. That's not permittable. So let's go ahead and see if we can split this. So now remember our rules for splitting. And I'll maybe just redraw down here. Our left node is going to come off, 4 by itself. Our right node, the 21, is going to come off. And the 11 is supposed to get inserted into the parent. Well, there is no parent, so that's a special case. When there's no parent, that means create a new root node with the 11 in it. So we'll put the 11 in that one, and we've got its left and right children being these two nodes, the 4 and the 21. Okay, so that's after adding the 25. Let's go, or after the 21, let's go ahead and add the 25. Well, it's greater than 11, so it belongs in this leaf node. And we have room for it, and we actually don't have to move anything down. That's an easy add. What about a 15? Well, again, greater than 11. I'm going to add it to this node, 15. And then after adding it, noticing that it's above my threshold, my order of 2, I'm going to split it. And again, splitting it in this case is going to leave us with a 15 in the left node, a 25. Maybe I'll draw that one over here. We're going to get a new node over here, the 25. But the 21 is going to get inserted up above here. So we're going to get this here. Now with a new node right here. And there we are. So after the split, we didn't have to split the root node, it had room, and so we're good. We can continue. So let's go with a 14. Well, get to our first node here. 14 is between 11 and 21, so it belongs in this node here. And when we add it, it bumps the 15 down. So we now get the 1. The 1, again, less than 11. We'll go in here, and again, it will bump the 4 over. Okay, we're starting to fill in those empty spots. We got one more here, but it doesn't look like the 9's going to go there. So it looks like maybe we're out of luck on these ones. We got our 9. Our 9's going to end up here, and again, we're going to get another split. So let's kind of be careful on this one. I'm going to start by, just sort of saying, well, the 4 here is going to get insert above. Okay, so the 4 will get insert above, and then we're going to get 2 new nodes, the 1 and the 9. Okay, so we've done the split. We split the 1 and the 9 off, and we've inserted the 4 above. But after inserting the 4 above, we see that we've run into the case where, again, we've got our root node here has size 3. We need to do a split on this node too. So again, splitting the root is the special case. We're going to go ahead and make a new root by inserting the 11 up, and then we're going to have 2 children. So, all right, so after that split, now got the two new nodes, the 4 and the 21. We've actually got a lot of free space now. We notice after splitting the root node, and maybe this is a good point. Let's just take a moment here to sort of think, how much free space do we really have? And by free space, what do I mean? I mean, how many nodes could we add without splitting the root again, busting out the root again? If we bust the root again, our height increases. If we do that, then we go to the next level or next depth of B tree. But on this 2-3 tree, we still have free space at this depth. How much free space do we have? Well, there's a couple that are easy to count. We got 1, 2, 3 here that we could just add with no splits whatsoever. But what we'll notice here, now maybe be careful, so let's say we did these 3 splits, and then let's say I put one here. This one would split, which would end up filling in this location here. Okay. But it would also create 2 new nodes for us. So we've done 1 here plus 2 more. So it looks like I'm going to do my count here. 1, 2, 3, 4. So we've got 4 plus the 2 new nodes. We're back to filled up down on the bottom. Well, we could do the same thing over here. Looks like I could do plus 1 more to split one of those nodes, plus 2 more to fill them up. That would fill up this one up here. Okay. Now notice that doing all that didn't even fill up the one at the top. So that was, let's see, that's like about 9 more adds. So even with 9 more adds, lucky adds, we could maybe have unlucky adds. That would cause something else to happen. But 9 lucky adds, and we'll fill up everything and not even split the top node. Okay, not even fill in that next node. How do we fill in the top node as well? That one's maybe a little trickier, but let's see where we're at. If after 9 adds, we said all the bottom nodes were filled up, and these 2 nodes were filled up too. Well, what we need to do to add a new one in here is bust one of these 2 nodes. So I can do that by busting one of its children, which would bust this node, which would bust it back up. And that would be enough to fill that up, but that would give us a whole bunch more free space as well. So it looks like 1 more would be enough to bust up again. But that would add us, I'm going to do a little quick head count here. 1, 2, 3, 4, 5. Maybe another 5 more nodes we could put on there as well. Okay. Now, if I really want to be clear what this number is going to be, and I've just been waving my hand at it a little bit here, what I could do is I could just go ahead and calculate from last day what's the maximum number of nodes I could put in a keys in a B tree or 2-3 tree of size or depth 2 here. And we know that there's some math we could maybe do there. Okay, something like this. All right, and then we could take the number that are actually in here and compare it to that number, and it should tell us how many we could fit in here without increasing to the next depth. Okay, that was just a little aside for us to start thinking about the math involved with the B tree. But let's continue building our B tree. So I want to add the 20 now. Now 20 is greater than 11, and look, of course we get unlucky right away. It's less than the 21, and it goes right here. So we kind of get unlucky. I said we could have filled up by filling in these other ones. Well, fine, we're going to split this one here. And we're going to split this one, and I'm going to be careful here. We're going to actually get 2 nodes, but the 15 node is going to be insert above here, which means it's going to bump the 21 over. So let's be careful. So after bumping the 21 over, we have the 15's been raised up with the 14 as its left child, the 20 as its right. Notice they've been split into 2 new nodes here. But the 21 moved over, and the little reference moves along with it, the reference to this node with the 25 in it. Okay, so didn't get very lucky there. Let's see how we do with the 2. Well, the 2, less than the 11, less than the 4, and it fits right there, so that's good. 17, greater than the 11, greater than the 15, fits here, but we're going to bump down the 20. All right, we've bumped down the 20. What about the 26 then? Greater than the 11. It's greater than 21, so we know it's in this node, and yeah, it actually fits right there. Okay, so now we've been getting a little bit lucky. What about our 13? Greater than our 11, less than our 15. Okay, belongs here if we bump down the 14. All right, filling everything up. What about our 7 here? Ooh, actually getting a little bit lucky with that one too. 7 is less than an 11. It's greater than our 4. So 7 bumps down the 9. Okay, well, there's no way to be lucky now. All of our leaf nodes are full up. I guess one way we could be lucky is if we busted one of these two, we had space here. But busting one of these ones is going to have a cascade going on. So let's see, a 24 looks like it's going to end up right here. Just going to pencil it in there for the moment. It's my 24. But the 25, it looks like, is going up here. Okay, so I'm going to split that one first, and then we'll deal with the cascade after that. All right, so we split the 24 and the 26. The 25 got inserted above, but now we need to split this node. Okay, so how's this going to work? Well, it looks like the 21 is going to come up above, and we're going to get it pointing at a new node with the 25 in it. And of course, we got to get rid of this 21 down here. Okay, so after that split, again, this node now split. We have a 25 and a 15 with the 21 inserted above. Okay, doing pretty good. And actually, that split was good and necessary because it gives us and frees us up the room for the 30. So the 30 is going to be greater than the 21, and it's going to be greater than the 25. So we get our 30 down here. All right, so we've practiced adding these 16 nodes into our B tree, and we arrived at this state, which is, pretty good practice. If you want to practice adding it, do, sort of what we've done here. Usually I say generate yourself some random numbers. Here I pick 16. 16 to 32, that's a good number if you want to practice doing your splits. You saw we got a couple cascades here, but we only got to depth 2. We could get to, a little bit further if we upped ourselves to 32 nodes, but there's a lot more work going on involved there. So usually I say just practice until you feel pretty confident and comfortable with what you're doing. Now, we didn't practice with redistribution here. If you did want to, you could practice doing these adds again with redistribution. But instead, I think what I want to do is I want to delete maybe a couple nodes, since deleting nodes is where we're gonna rely on redistribution first before doing a merge operation. All right, I think the node that I want to delete, kind of picked it strategically because I want to deal with a couple of possible cases we might get into. So I want to delete the 15, and I notice it's kind of in the middle here. It's holding all the tree together. Deleting the 15 could be a little bit problematic. So I'm going to go ahead and do it because the first thing we do when we delete is we find the node and we delete it. So let's go ahead and just, but God, okay. The problem is we've now arrived at this point where our invariant is disturbed, is been violated. In particular, we have one property that says we need to have the floor of d over 2 as a minimum number of nodes. In this case, our d over 2 would be 1. And so this node here has fewer than 1 keys in it, and as a result, it's in violation of that property. Now, luckily, this is also the property we say is sometimes omitted. So we might just say, oh, well, we're good. Okay, we're good with this one here. But actually, we've actually violated another property here, which is we're unable to search below this node now, this node that is empty. How do we know which child to access in this node? And so actually, here we are, we've got this empty node, there's a couple things violated, and we might think, how do we handle this? Now, our instinct might be, at this point, to try to look to one of our neighbors. We could look to one of our neighbors and say maybe redistribute. And in fact, that might be the right move, but in this case, we can't redistribute, as you can see from one of our neighbors. But it also might not work out exactly how we want. And so we might say, let's try and do a merge. And actually, if we try and do a merge, we're going to get ourselves into a problem where we're going to see a merge is not going to be helpful here. The merge, we can merge to the left with the 4, bringing down the 11, or we can merge to the right with the 25, bringing down the 21. If we do, whichever way we merge, let's say we're going to the left here, we're going to end up with 4 children for a node that can only have 3 children. So that's not possible. That can't be the move either. So far, we've tried redistributing with our neighbors. We've tried merging. That didn't work. Those were the options. That was what we were told. Well, I was a little vague when I said redistribute if possible. Redistribute how? Well, in this case, we can't redistribute with our neighbors, but we can redistribute with our children. Okay. We can redistribute with our children. And in this case, what I can do is I can bring the 14 up, or the 17 technically. But in this case, I'm going to bring up the 14, just arbitrarily choosing one of the two. And I'm good. Okay, that was it. Actually, all we had to do. That was considered a redistribution, but with my children. Okay, among my children. All right. Let's do another delete then. So I tried to delete something that was, going to cause me a problem, that 15, and it didn't cause a big problem because I could just redistribute with my child. Well, what if I keep going then? What if I want to delete 14 now? Okay, so again, let's delete it. And so we just saw that our instinct here, before redistributing with maybe one of our siblings, which we notice we can, or merging with one of them, we should try to try and promote up one of our nodes from below. In this case, maybe I'll be a little bit advantageous and say, look, there's the 17 still available. I'll pick the 17. Okay, and that leaves me with the 20 bumped down. Okay, well then, fine. I want to force my hand here. What happened? Let's keep going. Let's delete the 17 then. Okay, 17 deleted. So again, same situation. Now what do we want to do? Now how do we do this? Well, again, we're sort of in a state where we can't merge still because we have these 4 children that for three or 4 children that can occupy 3 positions. So what can we do? Well, again, why don't we just blindly, so far we've been picking them, we picked from the one that had enough space, but now neither of them have enough space. I'm just going to pick one. I'm going to say, fine, 13, you're coming up. Now what this actually did is it forced the emptiness down my tree. I had an empty node up here, but I forced the emptiness down onto this node now. And it's this node that I have to now deal with. And this one, again, I might say, hey, could I redistribute? Notice if there was enough here, we might redistribute. There might have been 2 actions when we said borrowing the 17. I might have actually stolen the 13 and then said, redistribute down. Okay, but here I've actually said, try it again. I can't this time. There's no way to redistribute. I don't have enough space. So that means I need to do a merge here. So to do the merge here, what we'd end up with is the 13 would come down and the 20 would merge. And we'd end up in this state. Now, this state is kind of where we just were. We have this empty node here. But now this empty node only has 1 child. And that's actually good. That's sort of what we should have if we have an empty node, is only 1 child, not 2 children. So by merging those 2 children below together to get this child. Now, sometimes we skip some of those intermediate steps. We say, okay, if we were at this case, we would just merge these 2. And now what do we need to do? Now we're going to merge with one of our neighbors. And let's say we merge with the 4 here. Okay, so I'm going to actually do this kind of easily. I'm going to take advantage that I can cheat a little bit. I'm going to move my 11 down because the 11 would come down and join. And then this child over here would now become the right child. Okay, so that means this node isn't going to exist anymore. And I brought the 11 down, so it looks like I need to redraw this node a little bit more carefully. Now this node just has a 21 in it and 2 children. Okay, maybe let's do one more because I thought, hey, I saw one that looks interesting. Let's try and do a 25. Okay, so let's try and delete our 25. Now again, deleting our 25 will just delete it. And we see we get in this interesting state. Now in this state, again, we might say, hey, I'm empty. I maybe want to merge with my buddy or even redistribute with my buddy. But again, we're in this place where I have these two children for a node with 0 elements. That's not proper. So instead, what I'm going to do is I'm going to promote one element up. Now again, let's go through the steps again. I'm going to actually say it's the 26, but what might happen is I might promote the 24 up. That would force the emptiness down into this node, which would say, hey, I need to redistribute from my neighbor, which would say, hey, push the 26 up and the 24 down. So the 26 actually ends up there. And just the 30 down here. Okay. And maybe let's try one more then, because again, if we do this one more time, if we try and delete the 26 now, then we don't really have the freedom to redistribute. And so what we want to do is do our merge, but remember we can't do the merge until we merge these two. So again, this would probably involve a few steps. The 24 would go up, we'd see the emptiness gets forced down, we get the 30 gets merged over, and now we can merge, or sorry, not merge, because we actually have too many nodes over here. We can now actually do a redistribution. So actually what will happen is the 21 is going to come down, the 11 will move up, and what do we do with this node here? Well, remember this is sort of the middle child that gets moved over. So let me fix my arrows here, and there we go, we're all done. Okay, so looks like what we did in this practice is we added our 16 numbers into our B tree, our 2-3 tree, and then I practiced by just deleting, it looks like 5 different numbers here, to try and show how we would use redistribution and merging to, again, shrink the tree back down again. All right, hopefully this has been enough practice on our B trees, so thanks a lot for watching, and we'll see you in the next video.